Good morning, students. I'm going to start the class. Uh, oh, sorry. Good evening, students. Okay, going to start the class. Today's class is very important, and you listen very carefully. If you have any doubt, you can write in the chat box. Okay, right. Good morning, students. I'm going to start the class. Okay, now the board is appearing now. Everything will be clear, right? In the last class, we discussed about the extrinsic semiconductors and intrinsic semiconductors. Extrinsic semiconductors are two types. What are they? Extrinsic semiconductors are two types. What are they? Extrinsic semiconductors are P-type and N-type semiconductors. P-type semiconductors holes are the majority charge carriers and N-type semiconductor electrons are the majority charge carriers. Now, today's topic is the PN junction diode. PN junction diode. How PN junction diode will be forms and how PN junction forms and what is PN junction diode, that all things I am going to explain. You listen very carefully. Okay, first of all, PN junction, what is PN junction and what is the PN junction diode? Okay, and for the purpose, is it clear, students? Is it appearing clearly? Yes or no? Is it clear? Right? Ganesh Chandra Kalindi. P-type and N-type semiconductors. External semiconductors are two types. Okay, P-type and N-type semiconductors. And now, okay, Sushmita. Yes, sir. Right. I'm going to start the class. You listen very carefully. Right. This is a germanium semiconductor. Germanium semiconductor. Okay, germanium is a semiconductor. And now, this germanium semiconductor, very carefully you have to hear. Okay. This is the junction which separates. Okay, it is the junction. Let us. What happening? Take 1 minute. It will be clear everything. Okay, and this is a material. Alright. In p-type semiconductor, what are the majority charge carriers? In n-type semiconductor, what are the majority charge carriers? Can you tell? In p-type, write in the chat box, what are the majority charge carriers in p-type semiconductor and what are the majority charge carriers in the n-type semiconductor? I want the majority charge carriers only. In p-type, majority charge carriers, n-type also majority charge carriers. And now we are going to discuss about the PN junction, right? This is my topic, PN junction. Now, what is PN junction? Then I will take a one semiconductor material. Okay, this is a semiconductor material. This is semiconductor material, for example, it is a germanium or silicon. Okay, this is semiconductor material. It is either germanium or silicon. Now, one side it is doped with the trivalent impurities. Trivalent impurities are added. Can you give the example of trivalent impurities? Another side we are adding the pentavalent impurities. Pentavalent impurities. This is the junction which separates the. This is the junction. How junction forms I will explain. When trivalent impurities are added to the pure semiconductor, then what happens? This will become p-type semiconductor, and this will become n-type semiconductor. You know that if we add the impurities to the pure semiconductor, then we will get the extrinsic semiconductor. If impurities are added to the pure semiconductor like germanium or silicon, then we will get as the extrinsic semiconductor. If extrinsic semiconductors are two types are there, one is p-type and other one is n-type. Okay, when we will get the p-type and n-type semiconductors, if impurity is the trivalent impurity, if trivalent impurity are to the pure semiconductor, then we will get the p-type semiconductor. If pentavalent impurities are added to the pure semiconductor, germanium, then we will get the n-type semiconductor. Right? This we discussed in the last class. And now in p-type semiconductor, majority charge carriers are the holes and minority charge carriers are the electrons. We know that one. We discussed it previously. Right? In p-type semiconductor, there is a vacancy is there. We are adding the boron for the pure semiconductor, right? We are adding the boron for the pure semiconductor. You listen very carefully here. Okay, if you have any query, you can write in the chat box. I am explaining everything clearly. Okay, for example, trivalent impurity is the boron. Boron is the trivalent impurity. Why it is said to be trivalent? Because it has the three valency electrons. It is added to the germanium, right? Germanium is the tetravalent pure semiconductor. Then at the moment, what happens? Every germanium has four valency electrons, but the boron has trivalent. Okay, it forms the three covalent bonds, but the one bond is incomplete, right? Here the vacancy is there to fulfill the fourth bond. This vacancy is called as the hole. Okay, this vacancy is called as a hole. Like this, if certain amount of boron is added to the germanium, in that lakhs of boron atoms are there, lakhs of holes are created. That's why holes are the majority charge carriers and electrons are the minority charge carriers. Why electrons are the minority charge carriers? Because here appearing so many electrons, only one hole is appearing. These electrons are not electrons. Actually, free electrons are useful for the flow of current. If one of the another covalent bond breaks, for example, some more electron jumps from here, covalent bond breaks means at the moment here one more hole will be generated, right? And this electron is said to be free electron. This vacancy is called as the hole. Due to the break of the covalent bond, electron hole pairs are generated. Due to the boron impurities, vacancy is created. This boron atom is the positively, it is not charged, but it requires one electron to fulfill the fourth covalent bond. You see here boron has the three valency electrons, but the boron requires four electrons to form the four covalent bonds. Is it right? It requires the four electrons, but valence electrons are only four. One vacancy is there, and that can be indicated like this. Okay, we have to write here minus along with that one hole, minus one hole, minus one hole. Okay, why we are writing the hole at here? Okay, why we are writing the hole at here? I will explain very carefully. You have to hear. Okay, this is the p-type semiconductor. Okay, because when trivalent impurity is added to the semiconductor, that will become p. And another side, okay, this will be another side is the pentavalent we are adding. So why we are giving this negative plus hole? Because here here the boron is there, boron atom. The boron atom require one electron, right? If it, that's why boron atom, if it gains the electron, if it gains the electron, then boron minus it will become, that means it will become the negative ion after gaining the electron. That means here the vacancy is there with the boron, right? That's why here we are writing the one atom, minus we are writing, Instead of that, we are writing the hole. That hole indicates the vacancy for electron. If the vacancy is filled, boron has a vacancy for the electron to fulfill the fourth covalent bond. To here, uh, we are indicating the negative because this hole from somewhere, if the electron gains and this bond fulfills, means what happens when the bond fulfills, somewhere electron came and this boron, this hole is filled, then at the moment boron acquiring the electron, that's why the boron become negative ion, right? Boron acquires the electron means it will become negative ion. If this is the hole, if the hole is filled with the electron, then it will become the negative ion, right? Similarly, if you go for the next, we will see this side pentavalent impurity we are adding. Pentavalent impurity we are adding. Pentavalent means example is what? Phosphorus, arsenic, antimony are the example. Phosphorus we are adding to the pure semiconductor. This is a germanium semiconductor. For this germanium semiconductor, I am adding the pentavalent impurity one side, trivalent impurity is another side. When pentavalent impurity is added, then phosphorus is a pentavalent, means 5 valence electrons are there, and it is added to the pure germanium. Germanium is the pure semiconductor. If phosphorus impurity added to the pure semiconductor, then what happens? Germanium has the 4 valence electrons, right? You see here, around the germanium 4 we wrote, around the germanium 4 we wrote, around the germanium 4 electrons we wrote, around the germanium 4 electrons, around the phosphorus I wrote the 5 electrons, 1, 2, 3, 4, 5. Right? In this, it forms the 4 covalent bonds. Phosphorus has 5 valence electrons. In that 4 valence electrons forms the 4 covalent bonds. 1, 2, 3, 4. 4 covalent bonds with the 4 neighboring germanium atoms. One extra electron is there for the phosphorus. This extra electron is it is not in the bond, it is freely, it is, there is a chance to escape from the valency band, it is also valency band. Other moment what happens, this will become the free electron, it can easily become the free electron. Now the phosphorus has the extra electron. If this electron loses due to any reason, the phosphorus become the positive ion. Now phosphorus is not have any charge, negative or positive, but the phosphorus is now neutral, but phosphorus has extra electron. If it loses extra electron, it will become the positive ion. We are writing like this: the phosphorus has one extra electron. If this extra electron loses, it will become the positive ion like this. Okay, we are writing positive ion instead of that one electron. Okay, when it will become the positive ion, if electron due to any reason, if it loses, I'm writing like this. Okay, if it electron loses means what remains? Positive ion will be remains. Why? Phosphorus is the neutral atom. If it loses electron, it will become the positive ion, because due to loss of atom, it will become the positive. And next, like this, I am drawing it here. Uh, Positive ion along with the electrons. Positive ion along with the electron. Electron is indicated with the dot, and hole is indicated with the circle, small circle. Okay, understood. This side p region, this side n region. Is it clear, students, till now? Is it clear? Write in the chat box. Okay, Suchita. Actually, the continuation is required. Oh, the last two classes, so many members absentees are there, and due to that, it is a problem for you to understand the concepts. Okay, and then even though try for it, I am revising the last topics also. Okay, listen very carefully and write it. And Ratika Pradhan Suchita Dhruva is giving the answer. Right, okay. Now, what happens at here? Till now, it is clear, na? Right. Now, just continuation. Here, one. This is a pure, totally germanium sample. Germanium sample. For that, one side is added with the pentavalent, and other side is added with the trivalent. When trivalent impurity is added to one side, this germanium become p-type, and another side we are adding the pentavalent, it will become the n-type semiconductor. Right? Then there is a layer which separates the two regions, that is called as the p-n junction. That is called as the p-n junction, because this side p region, this side n region, separates the two layers. In P region, what are the majority charge carriers? 1, 2, 3, 4, 5, 6. Like these holes are the majority charge carriers. But one or two electrons also available. And here in N region, electrons are the majority charge carriers. Right? Next. Next important point I am going to explain. How the PN junction formed, that we discussed it here. Okay. And the next one is that the two process will be occurs in the during formation of the PN junction. Here PN junction forms it here. During that, two processes will be occurs. One is that here in N region, okay, the two process during formation of PN junction, during formation of PN junction, two processes occurs. Following processes occurs. What are they? The first one is that diffusion, and the second one is the drift. These two processes will be occurs. What is diffusion and what is drift? You see here, diffusion of gas also, you know, that is due to the difference in the concentration. In the N region, more electrons are there. In the P region, more holes are there. This dot is the electron, and this small circle is the hole. And electrons moves from N region to P region because of electrons are less in P region, more in N region, right? Then electrons diffuse from N region to P region, and holes diffuse from P region to N region. And when electron moves from N region to P region, what happens? For example, this electron is moving from N region to P region, and this hole is moving from P region to N region. When electron and hole moves together, at that moment they will be neutralized with each other. Let this atom is gaining the electron in the P region. In the P region, you follow the cursor. Okay, in the P region, this is negative ion is there. This, if it actually it is not negative, okay, it is a neutral, but if it gains the electrons, it will become the negative ion. Then at that moment, what happens? This is the P region and this is the N region. When electron moves from N region to P region and the holes moves from P region to N region, they are neutralized with each other. At that moment, on both sides of the junction, what remains? When left side in the P region, if atoms gains the electron, and from N region to P region, electrons are moving, and these atoms which are present in the P region gains the electron. When they gains the electron, they acquire the negative, and these atoms which are in the N region, they losses their electrons. That's where they become the positive ions. And finally, we are and other finally we are getting a region which is free from the electrons and holes, and which are contains only immobile negative and positive ions, and this region is called as the depletion region. Like this, the depletion region forms. And then what is the diffusion process? Diffusion process means right, due to the difference in concentration, due to the difference in concentration, electrons moves from N region to P region, and holes moves from P region to N region, and this they will neutralize with each other on both sides of the junction. This is the junction. On both sides of the junction, what forms? Immobile positive and negative ions forms. Okay, immobile negative. Immobile means what? Immobile means they cannot move. Ions cannot move, right? And then remaining will be same holes only, there like this. like this. Remaining will not become the negative ions. Why? Only near the junction it forms. Here it has same. Okay. What happened? Why like this? I will explain clearly. You listen. Okay. And now what happens at here? Oh, when this starting at the starting formation of the depletion layer. Okay. Diffusion process I will explain. Okay. Due to the difference in concentration. Diffusion means what? Diffusion is the process. Okay. Due to the difference in concentration. Due to the difference in concentration. Due to difference in concentration. Electrons moves from where to where? Electrons moves from N region to P region. N region to P region. And holes moves from P region to N region. Right? Holes moves from P region to N region. And neutralize with each other. And neutralize with each other. This process is called as a diffusion. Okay, this process is called as neutralize with each other. This process is called as what? Diffusion. This is the diffusion process, diffusion of electrons and holes. In this process, what happens? In this process, on both sides of the junction, immobile negative and positive ions forms. Is it right? On both sides of the junction. Junction means what? A layer which separates the two regions. Right? One side P region is there, other side N region is there. That is the junction. Okay. And now this on one side negative ions forms and other side positive ions forms. And then this region, a region due to this diffusion process, a region forms which is free from mobile charge carriers. Okay, due to diffusion, near the junction, what forms? Near the junction, a layer forms which is free from mobile charge carriers, means no free electrons in this region. You see depletion layer, I gave this one. In this region, no mobile charge carriers, no electrons, no holes, right? Electrons and holes are not present. What present? Only negative ions in the P region, positive ions in the N region. And this region is called as, due to the diffusion due to the diffusion near the junction, a layer forms which is free from mobile charge carriers, is called as what? Depletion layer. Deplete means electrons and uh, holes disappeared here. It is called as a depletion layer or the depletion region. How the depletion layer formed, I explained. Due to the diffusion it will forms. And now I'm going to explain one more process. Before that, why all the other electrons here, this remaining electron also not moved? Why it is not moved from N region to P region? That question will come set here. Why other electrons? Why other electrons will not move from N region to P region and P region to N region? This is my doubt. Why in N region all positive ions forms and why not forms all the positive ions in the N region and all the negative ions in P region? This is my doubt. Can you write in the chat box? Write in the chat box. Okay. Is it clear till now? I am going to erase and I will continue now. Clear na? Right. How the depletion layer formed? Then why further movement of electrons and holes does not occur across the junction? Actually, what happened in the beginning? Electrons moves from n region to p region. See the diagram, left first diagram. Electrons moves from n region to p region, holes moves from p region to n region. They neutralize with each other. Why other some more electrons also there here? Why they will not move from n region to p region and holes does not move from p region to n region? If all moves means totally one side become positive ions, other side become negative ions, but it is not possible, right? Why? I will explain, right? After forming the depletion layer with certain width, okay, here this is the width of depletion layer, okay, this is the width of depletion layer, and after certain depletion layer, if for example this electron is again trying to move from n region to p region, if this electron trying to move from n region to p region, what happened? It is started at here, it started at here, like the electron is a negative charge, it is trying to go this side, you see, follow the cursor, and electron is going this side, this side, this side, this side. When electron is a negative charge, when it come to here, negative ion is there, this negative ion repels the negative electron, not allowed to enter into the p region. That's why this electron is not moves from n region to p region. And this is the whole is we can take relative to electrons, whole we can take as a positive charge. When the positive charged whole is trying to move from p region to n region, these ions never moves. This big one, and beside under inside I wrote minus, this is ion. This ion never goes, right? Ion are immobile in any way. In any case, ions not movable, right? Okay, ions cannot move. And now holes moving from P region to N region. When the hole tries to move from P region to N region, when it is cross the junction, after crossing the junction, here there is a depletion layer due to that positive ions are there in the N region. When the hole is trying to move this side, the hole is positive charged, they will be repelled with the positive ions. That's why what happens? Okay, when the holes are repelled by the positive ions, then not allowed to enter into the N region. That means the further movement of electrons and holes across the junction stopped by the depletion layer. Have you understood? Here the depletion layer is formed. The depletion layer not allow the further movement of electrons from n region to p region and holes from p region to n region, because when electrons trying to move this side, the negative ions repels. When holes trying to go that side, these holes are positive charged and these positive ions will be repelled. That's why not allowed to cross the junction. Okay, right. And then this is how the depletion layer opposes the uh, further movement of electrons. Next, I am going to give one point that here there is a complete across the junction. Here this is completely negative is there, and this is completely positive charged. It will become the positive charged. Then there is some potential difference across the depletion layer, because one is negative and other is positive. Then the potential difference is there, means then that potential difference across the junction in the depletion layer is called as what happens? Potential barrier. It is called as a potential barrier. Potential barrier, barrier potential. Why it is a barrier? Because barrier means it is a wall. It is not allow the holes to move from p region to n region, electrons from n region to p region. Then that's why this is said to be a barrier. Barrier forms. Depletion layer is also said to be barrier. Barrier means it is a wall. It is a wall with certain height. Wall with certain height. In order to move from here to here, then you have sufficient energy to jump and to cross the wall, right? And similarly, here the holes are there in the p region and electrons are there in the n region, but their movement will be stopped by this depletion layer which is formed across the junction, and this region is said to be depletion layer. In the depletion layer, one side negative ions forms, other side positive ions forms. The potential difference across the barrier, okay, is called as the barrier potential or the potential barrier. Like this potential barrier will be forms. Okay, right. Next, I'm going to erase this. You take the screenshot. I'm not giving the clear notes. I am explaining only. Okay. Now let us see how the electric field forms across the junction. What is the electric field across the junction? How the potential barrier formed that I explained. That potential barrier means what? Potential barrier. Okay, potential barrier. Potential barrier. Potential barrier means what? Potential barrier is the potential difference. Okay, potential difference across the barrier. Okay, potential difference across the barrier. Near the junction, one side negative ions forms, other side positive ions forms. One side negative, other side positive means there is some potential difference is there. Right? Potential difference across the barrier is called as barrier potential or the potential barrier. It is denoted with VB. It is denoted with V suffix B. Okay, right. This is about potential barrier. And now I am going to explain the electric field across the junction. How much electric field will be there across the junction? Before that, what is the value of the potential barrier for the germanium or silicon? For example, if the PN junction is made with the germanium semiconductor, okay, and then in case of germanium, you remember it, the potential barrier. In case of germanium, the potential barrier is 0.2 volts. Okay, and in case of silicon, okay, if n junction is made with the silicon, the potential barrier is 0.7 volt. Okay, right. And now electric field across the junction. You see here, this is the PN junction. Okay, this is the P region and this is the N region, and this is the junction. Okay, and in the P region what forms? In the P region negative ions forms, right? In the N region what forms? Positive ions forms. What they will do? Okay, here in the P region holes are there, right? Majority charge carriers. In N region what are there? Electrons are there. Majority charge carriers means more electrons are there. When holes are trying to move that side, this positive ions repel. Electrons are going this side. These electrons are negative charged when they are trying to go this side. You should follow the cursor. And the electrons are going left side. These holes repel. That's why the movement of the electrons and holes are stopped by this potential barrier. Okay, right? And the potential barrier is the just like a wall for the movement of electrons and holes not allowed to move, right? This is the depletion layer, it is called. And the depletion layer, the potential difference is called as the potential barrier, right? And due to this, some electric field will be produced across the junction. Okay, what is the electric field across the depletion layer? Electric field across the junction, electric field across the junction is what? Very nice topic actually. If you want to do the engineering or anything, then it will be very useful. Electric field formula is potential difference by distance. This distance we can take as d. Then we write as electric field across the junction is VB by d. You know formula, this formula. Electric field is equal to potential difference by width. Right? This we discussed in the previous lectures. Right? And next, this we can also write like this. That is the potential barrier is the opposite the motion. Okay, and this we can write like this is the potential barrier, right? Just like a wall. Okay, and potential barrier is the VB is the potential difference. This is the lower potential, this is the higher potential difference is VB. Okay, right. And now in this what is VB is the potential barrier. VB is the potential barrier. Okay, right. and you listen very carefully. D is the width of depletion layer. D is the width of depletion layer. And if you have any query, you write in the chat box. Do you have any query, students? Is it clear till now? Students, is it clear? Reply fast. Right. Till now we discussed about the PN junction. What is PN junction diode? This is very important application. PN junction diode. What is PN junction diode? PN junction diode means what? Then which is said to be PN junction diode? PN junction diode means, for example, this is a, and if trivalent impurity added to the semiconductor, it will become the p-type trivalent. That other side will become the n-type. Next, in last lecture, you see, if you have the doubt how p-type and type will be forms, right? There is a junction at here. There is a junction at here. Now, what we have to do it here? Two metal caps you have to fix on both sides of the PN junction. This side one metal cap you fix. Is it clear, students? Now, is it clear? Is it appearing? Yes, na, it's appearing na. Voice also clear na now. I think where it is stuck up, from there I will explain. From where it is stuck up, write in the chat box, students. Write in the chat box. Yes, na, it's appearing na. Voice also clear na now. I think where it is stuck up, from there I will explain. You tell me from where it is stuck up. Okay, now we are discussing the PN junction diode, right? Okay, PN junction diode again I am explaining. You see here, just this is the PN junction. Okay, one side P type and other side N type. This is the PN junction, and you see PN junction diode at here. What is the PN junction diode? This side, one side is the P type and other side is the N type. Okay, this is the PN junction diode. Just you take a germanium semiconductor, one side is doped with the trivalent impurities. When trivalent impurities are added to one side, okay, when trivalent impurities are added to the one side, at that moment, this will become the p-type semiconductor. If pentavalent impurity added to the pure semiconductor on the other side, it will become the n-type. This is the junction, and these are negative ions, and these are the positive ions forms in, that is a depletion layer. How depletion layer forms just now we discussed. And the holes are the majority charge carriers in the p region, electrons are the minority charge carriers in the electrons are the majority charge carriers in the n region. Okay, and what we are doing it here, two metal caps we are adding on both sides to take as terminals. If this is metal, then what we can do, we can take two terminals, and then this device, just if you add the metal caps on both sides of the pn junction, that is called as the pn junction diode. Diode means two terminals are there, two terminals are there. It's a device which has two terminals. If two metal caps are added on both sides of the pn junction, then it is called as a pn junction diode. Okay, right, pn junction diode. I'm going to erase this. Otherwise I will do like this. Right, now what is the PN junction diode is a symbol. After finding the diode only, LED TVs we are using the LED. Okay, LED is a light emitting the diode. After invention of the diodes only, total electronics are changed. Right, now you see here, what is the symbol of the PN junction diode? Symbol of PN junction diode I want. Symbol of PN junction diode. What is the symbol? The symbol of PN junction diode is, this is the symbol you see here. This is the symbol of PN junction diode. Okay, this is the symbol of PN junction diode. You should remember. Okay, right. This is the P region left side. This is the N region, and this arrow we are giving the arrow. This is the arrow, na? Arrowhead. Right. This arrowhead indicates head of arrow. Okay. This head of arrow indicates direction of current in the conductor. Direction of current in PN junction diode. PN junction diode. Direction of conventional current is given by this. Okay, this is about PN junction diode. And now one more point, actually during formation of the PN junction, there is a two process will be occurs. One is the diffusion I said, but the second process till now I am not explained. That is the drift. What is the drift? What is the drift? Drift means what? I will explain very carefully. You have to listen very carefully. And this is the previous question. All are the previous questions. How depletion layer forms, how potential barrier forms, and what are the two processes occurs during formation of the PN junction. All are the previous questions. Everything is very important. You listen very carefully. Okay. And this is the drift I am going to explain. And this is the PN junction. Okay. This is the PN junction. And this is the P region, and this is the N region. This is the junction. This is the junction. Junction means it is a layer which separates the two regions. Okay, right. In the P region, holes are the majority charge carriers. In the N region, electrons are the majority charge carriers. In N region, electrons are the majority charge carriers. But what happens it here? One or two electrons also there in the P region. Holes are majority, electrons are minority. In N region, electrons are majority, holes are minority. Small circle is the hole. Small circle is the hole. Okay, this dot is the point is the electron. Okay, how majority, how minority in the last class we discussed. Okay, right. And now what happens at here, at the depletion layer, there is some electric field is there. In the P region, negative ions forms, right? In the P region, negative ions forms. Why? In the P region, the holes are majority charge carriers, na, they will filled. They gain the electrons. That's why the atoms which are in the P region, they gain the electrons from N region. That's why they will become negative ions. In the N region, atoms electron loses. That's why they will become the positive ions. What happens? One side positive, one side negative forms. That is called the depletion layer. And this layer width is the width of depletion layer. Width of depletion layer I said W. But here electric field will be forms. This is the negative ion. This is the negative for completely. This is completely positive. There is some potential difference is there. That potential difference is called as the potential barrier. barrier potential, and then what this will do, this will not allow the holes to move from p region to n region, electrons to move from n region to p region. It will act as a barrier and wall opposition for the movement. Then what is the drift? Here electric field will be forms in the depletion layer from n region to p region, because positive to negative is the electric field. Okay, positive to negative is the electric field. Then due to the electric field, what happens, these electrons in p region, minority charge carriers, you see here minority charge carriers, minority charge carriers are there in the p region, electrons. These electrons are attracted by the positives in the n region. That's well, the due to electric field across the junction, due to electric field across junction, what happens, electrons means minority charge carriers, electrons moves from where to where, electrons moves from p region to n region, p region to n region. Actually in p region totally holes are there, but or one or two electrons also there, they will go due to electric field, right? And p to n region, and the holes moves from, 1 minute, I'm setting this. It is going that side, this side. Right? Okay. Now, listen very carefully. Due to electric field across the junction, due to electric field across the junction, minority charge carriers, electrons, moves from p region to n region, and electrons are in majority charge carriers in the n region, but the holes are the minority charge carriers, and holes moves from, and holes moves from, holes moves from n region to n region to p region. This process is called as, this process is called as what? Drift. What is the difference between the drift and diffusion? Diffusion is the, actually in the beginning formation of depletion layer, n region more electrons are there, p region more holes are there. The electron movement from n region to p region, hole movement from p region to n region, that is called as the diffusion. Okay, that means, okay, if you take this one like this is the p region and n region, this is the p and this is n. Okay, and electric field is this is the positive ions and these are the negative ions. Electric field is right side, right? And now diffusion of electrons left side will be there, diffusion of electrons. Diffusion means what? Movement of majority charge carriers, majority charge carriers in n region moves from p region, in n region moves to p region. Majority charge carriers in the whole, in the p region are the holes, they will move to n region during formation of the pn junction. Okay, this is the p region, and here majority charge carriers holes, and here majority charge carriers are electrons. These electrons goes this side, right? And then that's where here the positive ions forms, and here holes goes that side, here negative ions will forms because they are gaining the electrons, and this is movement is called as what? Drift. Drift is the motion of the charge carriers, motion of the majority charge carriers. Okay, drift is the, diffusion is the motion of the majority charge carriers, but the drift is the motion of diffusion of electrons from n region to p region, because in n region majority more electrons are there, that's why they will go to p region. That is the diffusion due to the difference in concentration. And here more electrons are there, here less electrons are there, that's why electrons moves from n region to p region. That is the diffusion due to the difference in concentration. Drift means what? Due to electric field at here, this electric field, positive ions attracts the electrons. That is the drift. That means the drift of electrons is right side. Drift of electrons is right side. Drift of electrons. Okay. Right. And actually, movement of minority charge carriers. Movement of minority charge carriers due to electric field is called as drift. Is it clear, students? Drift and diffusion. Okay. Is it clear, students? Write in the chat box. What is the drift and what is the diffusion? Presence of hole. Priya Mato. PN junction diode again. Sir, presence of hole in N type is because of diffusion. Sir, presence of hole in N type is because of diffusion. In N region, holes are there, minority charge carriers. That is not diffusion. Actually, during formation of the depletion layer, you understand during how N type will be there and how P type will be there. You study the P type semiconductor alone only. You study the N type semiconductor alone only. In N type semiconductor, majority are the electrons. If you go for N type semiconductor, more electrons are there, less two holes also there, one or two holes also there, and electrons are the majority and holes are the minority. In P region, holes are the majority and electrons are the minority, because the continuation is very important. Continuation is very important. I'm going to erase this. Okay, this is about n junction diode and formation of depletion layer. If you have any query, you write in the chat box. Do it fast, students. Write in the chat box. I will explain everything. Whatever the query you can ask. Whatever the doubt you have, you can ask me. I will explain. Next one is the PN junction diode. PN junction diode. PN junction diode connected in circuit in two ways. PN junction diode is a device, electronic device, that is connected in circuit in two ways. In two ways. In two ways we can connect the circuit. What are that ways? The first one is the forward bias. Second one is the reverse bias. Forward bias, and the second one is the reverse bias. What is a forward bias first? What is the forward bias? How to connect the diode in the forward bias? You listen very carefully. What is forward bias? How we will connect the diode in the forward bias? Okay, you see here very carefully. This is the PN junction diode. This is the junction, and in the P region negative ions are there. In N region positive ions are there across the junction, right? In the P region holes are the majority charge carriers. In N region electrons are the majority charge carriers. Now the P region, this is the PN junction diode. Okay, the P region of the PN junction diode is connected to the positive terminal of the battery. Okay, and N region is connected to the negative terminal of the battery. Like this we are connecting. This is said to be forward bias. But we have to do it here. We have to connect P region to positive terminal. PN junction diode is said to be in forward bias if P region connected to the positive terminal of battery and N region is connected to the negative terminal of battery, then the PN junction diode is said to be in forward bias. Then we can draw this circuit diagram also. We can draw like this. This is the symbol of the PN junction diode. This is the P and this is the N. This P is connected to the positive terminal of the battery and N is connected to the negative terminal of the battery, and here we will take 1 milliampere to measure the current, and here we will take one resistance also, right? This is the variable, and along with one plug key we can connect, and we can connect to the right. This P region connected to positive terminal of the battery and N region connected to negative terminal of battery, then the PN junction diode is said to be in forward bias. To measure the potential difference, we connect one battery at 1 voltmeter. This is the voltmeter to measure the potential difference across the PN junction diode, and this milliammeter is the measures the current. Okay, right. Now, when we said that the PN junction diode is in forward bias, okay, if P region is connected to positive terminal, if P region or the P type of semiconductor, okay, P type is connected to what? If P type is connected to positive terminal and N type, N type, this is N type, is connected to negative terminal of battery. Just it is easy to remember. P connected to positive terminal, N connected to, this is the PN junction diode. PN junction diode has P region, N region. P region connected to positive terminal, N region connected to negative terminal. Then the PN junction diode is said to be in the forward bias. P type is connected to positive terminal and N type is connected to negative terminal. Then PN junction diode is in PN junction diode is in forward bias. Is in forward bias, right? In forward bias, what happens? What happens in the forward bias? Holes are the positive charged, okay, related to electrons. Electrons are the negative charge. These negative electrons are connected to the negative terminal of the battery. This negative will repulse the negative. That's why the electrons moves towards the junction. Electrons moves towards the junction. Why electrons moves towards the junction? Because they are repelled by the negative terminal of the battery. And the holes are positive charge, they goes to right side because they are repelled by the positive terminal, they will go to right side, right, like this. And if sufficient voltage is given, at that moment what happens, these holes, sufficient voltage, if we applied voltage is V, if sufficient voltage is given, if applied voltage is greater than the opposition voltage, here opposition voltage are there. This hole is not allowed to enter into the N region because this positive ion repels. This barrier potential not allow the movement of the electrons and holes across the junction, right? Then what happens? Further movement is stopped at here. Okay, movement of electrons and holes across the junction is stopped, and then after that, if you apply the potential that is more than the opposition potential, then they can cross the junction and the current starts. More holes enter into the N region and more electrons enter into the P region. Then this process will continuously occurs. Some current will be generated. Some current is passes in this. Right. That means diode conducts in the forward bias. In forward bias, what happens? In forward bias, in forward bias, width of depletion layer, what happens to width of depletion layer? Width of depletion layer means a layer free from electrons and holes. Now the holes are entering into the depletion layer. That's why the width is decreases. In forward bias, width of depletion layer decreases and it disappears also. Right? In forward bias, current flows, na? Current flows. In forward bias, diode conducts. Diode conducts, right? Na? Current passes through it. Current passes through it. Is it correct? And in forward bias, it offers less resistance. Okay. In forward bias, diode conducts, current passes through it. In forward bias, diode offers less resistance. More current is passing. That's why diode offers less resistance. In forward bias, diode has less resistance. Less resistance. Next. I'm going to erase. Why it is not erasing? Now, carefully you have to hear. What happens to the potential barrier in the forward bias? Is it decreases or increases? Potential barrier. Some more points I am going to give. In forward bias. In forward bias. Okay. In forward bias, potential barrier decreases. Potential barrier decreases. Barrier decreases. Right. You see here, this is the original potential barrier. This is the one. It is the original potential barrier. Right. Its value is VB. But now we are applying the potential. If applied potential is less than VB, okay, net barrier potential is what happens. This is the barrier potential, barrier opposition, and now the potential will become like this too. Potential will be decreases. Now the net potential become VB minus V. Why the potential is decreases? Okay, net barrier potential I will tell. Net barrier potential. Net barrier potential will become VB minus V. Why? If VB minus V लिख सकते हैं नहीं तो V minus VB also you can write. Net barrier potential is VB minus V. VB is the barrier potential barrier, and V is the applied potential. Applied potential. Why it is decreasing? Why the here in these two diagrams are there? One indicates that, okay, in the above figure, one indicates in above figure. One indicates potential barrier without battery. Potential barrier without battery is more. Without battery is more. But 2 is what? Potential is decreased now. Why? Applied potential we are giving. Applied potential is opposite to barrier potential. That's why net potential will be decreases. This is the potential barrier with battery. Potential barrier with battery. In exam they will ask like this: how you will connect the PN junction diode in forward bias with the battery? First question. Second question: what happens to the potential barrier and depletion layer in forward bias? Whether the diode conducts or not conducts in the forward bias, whether current passes or not passes, like this they will ask the questions. Next one is the reverse bias. Next one is the reverse bias. Is it clear, students? Write in the chat box if you have any query. And the next, in the reverse bias, how to connect the PN junction diode? This is the PN junction diode you see here. This is the PN junction diode. This is the P region and this is the N region. Okay, this is the junction. How P region forms, how N region forms. Okay, that all things based on the previous. It is just like a serial. And here the negative ions are there. Here positive ions are there. You know that this how will forms. Just now I explained. Here holes are there. Majority charge carriers. Majority charge carriers are the holes. Here electrons are the majority charge carriers. What you have to do it here? This is the PN junction diode. This is the PN junction diode. Now you connect the P region to the negative terminal of the battery. N region connected to the positive terminal of the battery. N region connected to the positive terminal of the battery through a resistance. Now this is said to be reverse bias. Okay, very simple it is. Just you have to. This is the PN junction diode symbol. Diode is said to be in is said to be in reverse bias. Okay, this is about reverse bias. Right, what we have to do it here? The P region you see here. This is the PN junction diode, and P region is connected to negative terminal, and N region is connected to positive terminal. Then the diode is said to be in the P connected to negative, N connected to positive. That diode is said to be in the reverse bias. Okay, this is the circuit diagram in the reverse bias. Now we will go for the continuation. In the reverse bias, what happens? Whether it will conduct or not conducts, and whether the current flows or not flows. That we will discuss now. You will listen very carefully. Within 5-10 minutes, I am going to close the class. Okay, you listen very carefully. PN junction diode is said to be in the reverse bias. Now, in reverse bias, what happens? These are the holes. Holes are the positive charged. They are attracted by the negative terminal. They will move away from the junction. These electrons are the negative charged. They are attracted by the positive terminal. They will also go away from the junction. Due to that, what happens? This region which is free from here, electrons are going this side. These atoms, the atoms which are at here, they loses the electrons. Here also positive ions becomes. Here negative ions becomes. This width of depletion layer will be increases. That means in reverse bias. In reverse bias, what happens? These holes are going this side, electrons are going this side. This region which is free from electrons and holes, that region will be increases. Electrons are going this side, holes are going this side, holes are going this side, electrons are going this side. That's why what happens? A region forms which is free from mobile charge carriers. That is a depletion layer. This is a depletion layer. Its width will be increases now. That means in reverse bias, width of depletion layer increases. In reverse bias, width of depletion layer increases. And in reverse bias, diode does not conduct. In the reverse bias, diode does not conduct. In reverse bias, diode offers high resistance. Why? Actually, electrons are not crossing the junction. Holes are not crossing the junction. This is the junction. This will become in this region. Electrons and holes are not moving. That's why this will become the insulator. Then this will become the open circuit. In that current will not flow. So in reverse bias, diode offers high resistance and current does not flow. But small current flows. Small current flows due to minority charge carriers. Minority charge carriers means current does not flows means diode not conducts it here. Not conducts, but small current flows, but that is negligible. Small current flows due to minority charge carriers. What are the minority charge carriers? In this, one or two electrons also there. One or two electrons also there. These electrons are negative charged. They are repelled by the negative terminal. They will go that side. In this, one or two holes also there. Holes are positive charge. In N region, electrons are the majority. See the picture. In the P region, holes are majority, but one or two electrons also there. That electrons are connected to negative terminal. They are repelled by the negative terminal. That's why they will cross the junction. They will go towards the junction and cross the junction. Then the current will be flows. In the N region, electrons are the majority charge carriers and holes are the minority charge carriers. One or two holes are there. They are the positive charge. They are connected to positive terminal. They are repelled and they will go this side. And due to that, small current will be flows. Small current flows due to minority charge carriers. Okay, small current flows due to the minority charge carriers. And what about the potential barrier? In reverse bias, potential barrier also decreases. Potential barrier decreases. Barrier increases. Depletion layer increases means automatically potential barrier also increases. Potential barrier also increases. Within 2 minutes, I am going to close. Now, we see the effective potential. What happens at here? Effective barrier potential. Okay, this is the figure. This is the barrier potential. This is the barrier potential without battery. Okay, barrier potential without battery. One is the barrier potential without battery. Next, if you connect to the battery, what happens? Okay, depletion layer is increasing. That's why the potential barrier also increases. It will become 2. 2 is the barrier potential with battery. This is the V plus VB. Okay, effective barrier potential become V plus VB in the reverse bias. Okay, right. This is about the PN junction diode and how it will be connected. Saurabh Kalindi, explain the reverse bias again. Okay, within once again I will explain and I will close. Reverse bias means what? You see this diagram. Right, this is the reverse bias. Right now, this is the about reverse bias. Now you see the reverse bias. What happened? P region connected to negative terminal of battery, N region connected to positive terminal of battery. Then the PN junction diode is set to be in the reverse bias. The holes are the majority charge carriers. They are in the P region. These they will be attracted by the negative terminal. Electrons are the majority charge carriers in the N region. They are attracted by the positive terminal because electron negative charge holes are this is battery is the positive terminal. This positive attracts the electrons this side, and the holes attract this side. The holes are positive charge, they are connected to negative. That's where the holes go this side and electrons goes this side. That's where what happens at here, there is no electrons and holes which are crossing the junction. That's why this will become a break open circuit. In this movement of electrons and holes is not occurs when the in the open circuit current does not flow, the net current in the reverse bias becomes zero. In the reverse bias diode does not conduct, but when the electrons goes holes goes this side, the depletion layer will become now up to here, for example, up to here increases, next electrons goes this side means again depletion layer will be increased. Depletion layer means what? In that electrons holes are not there, that hole goes this side means again here it will be free, right? Hole go this side means this will become free, no, free from holes. Then the width of depletion layer will be increases in the reverse bias. Then the potential barrier also increases automatically, because here what happening, potential barrier is based on the width of depletion layer. That's why then potential barrier also increases in the reverse bias. Okay, this is about reverse bias. In the reverse bias, diode not conducts, but due to small minority charge carriers in the p region, one or two electrons also there, they are repelled by the negative terminal. That's why they are repelled means they will go towards the junction and they will cross the junction. And in the region, holes are the majority charge carriers. Sorry. Holes are the minority charge carriers. They are positive charges. They are connected to positive terminal. They are repelled by the positive terminal, and they will go towards the junction. When the electrons and holes cross the junction, then some current will be generated. That is the current due to minority charge carriers. That's why small current flows in the reverse bias. Diode does not conduct, that is negligible. Okay, right. Thank you to all. Closing the today's lecture.